Today we are going to study about the applied maximum and minimum problems, and I have tried to find some of the questions where you can find the difficulty, and let's discuss one by one about these problems. So here is the question, that is, find a number in the closed interval such that the sum of the number and its reciprocal are as small as possible or as large as possible. So let's see how to solve such kind of the questions. The first thing is that whenever we have any question in which the optimization uh, has been asked to determine, in which we have to find out whether the area is maximized or minimized, or the numbers after adding up if their product is getting maximized or minimized and so on, then we need two kinds of the equation. The first equation is called the constraint equation, and the second equation is said to be the primary equation or the objective equation. So whatever you like, you can name it like that. Okay, so objective or the primary equation and the constraint equation. Now what we have to do in the objective equation or in the constraint equation. So objective equation is the equation which is which is given to us. Okay, so like for example, here they are asking you that the sum of the number and its reciprocal. So you have, that is the objective equation. And what is the constraint equation? That the constraint equation with the equation which you have to minimize or maximize by taking the derivative of that equation. So let's first of all write the main primary source of the equation. So here they are saying that the sum of the number and its reciprocal. Okay, so let's suppose there is a function, and in that function there is a number. So let's suppose the number is x and its reciprocal. So let's suppose the reciprocal of that number is 1 over x, and you have to find the sum of these two functions. So what is the first thing you have to do? You have to find out the sum of the number and its reciprocal. The first thing is that you have to take the derivative of that function in order to find the critical numbers. So we know that the derivative of x is 1 and derivative of 1 over x is negative 1 over x squared. Now make that derivative equals to 0 and solve for x. So bring the 1 on the other side. We will get negative 1 over x squared, or even you can bring the negative on the other side. So positive 1 over x squared equals to 1. Now cross multiply. On cross multiplication you will get x squared equals to 1. Now take the square root on both sides. On taking the square root, we will get x equals to positive and negative 1. Now here we got the two numbers, 1 x equals to plus 1 and 1 x equals to negative 1. Now have a look over here. So here look at the closed interval that is given to us, that is half and 3 by 2. So we need the x value which is within the interval. So you know that negative 1 is out of the here, okay, out of the closed interval. So we will not take negative 1 as our critical number. In our scenario, x value is equals to 1. So now we have three values. One is the half, one is the last value of the closed interval, and one is the critical number that we found. Now let's put these values one by one in the equation, original equation, to find the y values. So write down f of half equals to. So in place of x, substitute the half. So half plus 1 over 2. So we will get half plus 2, that is 4 plus 1, that is 5 over 2. That means that is our 2.5. Now put f of 1, the other number, write in the here f of 1 equals to 1 plus 1 over 1. We are just substituting 1 in our original function. So 1 plus 1 gives us 2. Now the last number, that is f of 3 by 2 or 1.5, put it in the original equation. So 1 plus 1 over 1 over 2. So we will get, y1, it should be over 3 over 2. 3 over 2 plus 1 over 3 over 2. So we will get here 3 over 2 plus 2 by 3. So we will get here 6, and 3 times 3, 9, plus 4, 10, 11, 12, 13. So 13 over 6 we will get our next value. Now just see that which value is the highest value and which one is the lowest value. So first of all, you have to find out the smallest possible number. So smallest possible number, you can see, first of all, write the 6, 13. 13 over 6 we will get here. Here if we divide the 13 by our 6, so 6 times 2 will get 12, and 1, and then put the point over here. So it will be something 2.1. Okay, so our smallest value is f of 1 equals to 2. So our answer for as small as possible will be f of 1 equals to 2, and the largest value will be 2.5, that is f of half equals to 5 over 2. So this is how we have to give our answers. Now here is a question in which they are asking a rectangle is to be inscribed in a right triangle having the sides of length 6 inch, 8 inch and 10 inch. Find the dimensions of the rectangle with the greatest area, assuming the rectangle is positioned in the figure as given up here. Now let's try to find out that what they are asking. So for example, there is a rectangle. So here the rectangle, the area of the rectangle has to be increased or decreased. Okay, has to be minimized over here. So they are talking about the rectangle. So what is the area of the rectangle? So area of the rectangle is x and y, length into width. So here, let's suppose this is my x and here this is my y, I'm saying. Now how to determine the x or the y values from the given equation. So you can see you can see that there are two similar triangles here. So let's see here, the first triangle is the big one with the dimension 6, 8 and 10, and the other triangle is over here, the small one which I am coloring from the yellow one. So what are the dimensions of this small triangle? So from here till here, if the dimensions of this rectangle, this side is y, so from here till here, you can clearly say that the dimension will be 8 minus y. Similarly, if this part of the rectangle we said it is x, so the smaller part from here till here, it is our x part. Okay, so now taking the advantage of similar triangles, let's see here just to show you that this is my small triangle and this is my bigger triangle. So the dimensions of the bigger triangle are given in the question, that is 6 and 8. And the dimensions of the smaller triangle, we can say that this value is x and the other here it is 8 minus y. Put these, first of all find out, okay. Let's take the ratio of these things. So we can write the base by the base. So the base of the smaller triangle divided by the base of the bigger triangle. Now the perpendicular side of the smaller triangle divide by the perpendicular side of the bigger triangle. Why we are doing this? We are doing here, the reason is that this equation, if we see here, we have two variables x and y. We need to convert them into one variable. So better to change the y into x. You can change the x into y also, but I prefer to change the y into x. Okay, so cross multiply, we will get 6. 8 minus y equals to 8 times x, 8x. Open the brackets by using the distribute property. So 6 times 8, you will get 48 minus 6y equals to 8x. We are solving for y. Okay, so let's bring the 6y here to make it positive, and bring the 8x here to, even if it is negative, we have no problem. So 48 minus 8x. Now divide the whole equation by the 6 to get rid of this 6 and find out the value of y. So 6 times 8 gives you 48. So you will have 8, and 8 over 6 will gives us 4 over 3x. So here is the value of our y. Now put this value of the y in the equation of area, so that you can have only one variable. So let's see here what we will write here. So area equals to x, and in place of y we will write 8 minus 4 by 3x. There. Okay, open the bracket. Open the bracket. So we will get x times 8 gives us 8x minus 4 by 3x squared. So our equation here is our constraint equation, which is given in one variable. Now take the derivative of that equation. So derivative of 8x is 8, and derivative of 4 by 3x squared will be 4 times 2 gives you 8 over 3. X from the power subtract 1. So this is our equation. So now make the equation equals to 0 to solve for x. So bring the 8 by 3x over here on the second side. On the other side we will get 8 over 3x equals to 8. Divide both sides by 8 by 3 or multiply both sides by 3 by 8. So you will cancel this one. X equals to 3. So this 3 is the value through which we can find out which makes the area greatest possible. Now let's see whether we are on the right side or we are wrong. So let's see, this is our 3, right? Now put this 3 in the first derivative test in order to show that yes, this is maximizing our area. So put it in the first derivative here. If I take the 0, so of course I will get the 0 as my derivative. This is my derivative. I'm so sorry. This is my derivative. So if I take the 0 in and substitute in place of x, I will get 8, which means it is a positive number. And if I just change it into, for example, if I take 4, so 4 times 8, 32, and it will gives you negative 24. So that is my negative number. So I will get, you can see that on the 3, I have a relative maximum. Okay, let's find out the y value, okay, because it is important to find for the y, for the area to determine the y value also. So in place of x, you substitute the value of x, that is 3. So we will get y equals to 4. Now the area the maximum area equation is a equals to xy. So you can say 3 into 4, that means the area is equals to 12. Now here they have the inches, everything is given in the inches, so your units will be inch square. So that is our final answer. Since we are asked to find the dimensions, so if you do not find the area finally 12 inches square, it's okay, because as far as they are asking for the dimensions, so you will say x equals to 3 inch and y equals to 3 inch are the dimensions of the rectangle. I hope that you understand. If you do not understand, then just write the comments or send me the questions so that I will make a detailed video about such kind of the questions. Let's move to another question. Okay, so there is another question, that is a garden is to be laid out in a rectangular area and protected by a chicken wire fence. What is the largest possible area of the garden if only 100 running feet of chicken wire is available for the fence? So let's see what are the two equations we have, which one is the constraint and which one is the objective equation, which one is the primary equation. So primary equation, you can say that the garden consists of 100 feet of chicken wire, means there is 100 feet of chicken wire is the garden is surrounded by 100 running feet of chicken wire. So it means, and another thing is that the garden is in the rectangular shape. So you can say easily here, let's suppose this is your x value, this is the y value, this is x and this is y. So you can find out that the parameter of the garden, of the rectangular shape garden, is 2x plus 2y, and the complete parameter, because here the chicken wire is x and y values, so this is completely equals to 100 feet. So 2x plus 2y equals to 100. Now this is your objective or the primary equation, and now you need to find out the area of that rectangular shape garden, and it has to be so that it is the maximized area. Okay, so now the formula of the area is x times y for the rectangle. Now here you can see that there are two variables, x and y, so we need to convert the y into x value. So from where we can do it? We can do it from our primary equation. So bring the 2x here. So I will get 2y, sorry, 100 minus 2x. Divide the whole equation by the 2 in order to get the value of y. So that will be 50 minus x. Now put this value of y in our constraint equation so that our constraint equation will consist of only one variable. So y in place of y, substitute 5 minus x. Open the bracket, so we will get a equals to 50x minus x square. Take the derivative to find the x value. So we will get 50 minus derivative of x square is 2x. Set the equation equals to 0 in order to solve for x. So 50 minus 2x equals to 0. Bring the 2x on the other side. We will get 2x equals to 50. Divide by both sides by the 2 and we will get finally x equals to 25. Now the unit will be feet. Now what is the y value? Put the y values, put the x value in this equation of the y, that is 50 minus x. So y value is also equals to 25 feet. Now let's try to find out the area. So just put the x and y values. So a equals to 25 times 25. Right, 25 times 25, that means the x value put here, that is 25, and y value is 25, which will gives us 625, and the unit will be feet square. Just to find out whether we are going on the correct path or not, you can write here the 25x value over here and put it in the first derivative, that is 50 minus 2x. Take any value before the 25, put it here. So let's suppose x equals to 0, we will get a positive number. And if we write here 26, so let's suppose it is 50, so that will gives us minus 100, and minus 100 plus 50 gives us minus sign. So you can see that yes, on 25, when x equals to 25, we would have a largest possible area. So that's all about the fencing questions, and let's solve another kind of the equation or the optimization problem. So here we have another problem of the cardboard or the open box, and they are saying that the open box is made up of 60-inch and by 16-inch by 30-inch piece of cardboard. By cutting out squares of equal size from the four corners and bending up the size as given in the figure. What size should be the squares to be obtained a box with the largest volume? Now remember that if the cardboard is given to us, okay, let's see here that what I'm trying to make, if there is a cardboard which is given to you and you want to cut the four corners from here. So here you cut, here you cut, from here to you cut, and from here you cut. So let's see this part, this cutting part, name it as X. And since all the corners which you are cutting are of equal size, so let's suppose this is X and here this is also X. This cut part is X, this cut part is the X, and this cut part is the X. Similarly, this part is X and this part is also X. Now after that you fold those part which are cut from the box, and in order to fold them and make the box. Okay, so now look at this. If the whole from here till here, okay, the cardboard is equals to 30 inch, okay, it is equals to 30 inch. So what do you feel that this would be, this would be equals to, and if this remaining part would be equals to what? So if from the 30 you cut one x part and another x part, so of course 30 minus 2x is left. Similarly, if you see here that from here till here the width of the cardboard is 16 inches. Now if you cut one from here x side and here x side, so what do you think that the remaining part or this part would be? Of course this part would be 16 minus 2x. So that's all. Now they are asking you to find the volume, the largest volume. It means your constraint equation is volume. Okay, so let's suppose the formula of the volume is length times width times height. So what is your length? Yani after folding, the length is 30 minus 2x. What is your width after cutting? It will be 16 minus 2x. And what is your height? Of course, the cut part, that is x. Because when you fold it, it becomes the x height. Okay, now we have this equation. Let's try to open all the brackets and then take the derivative, solve for x, and we are done. So let's try to open the bracket. So 30 times 16, it gives us 480. 30 times negative 2x will give us negative 60x. 16 times negative 2 gives us negative 32x. Negative 2x times negative 2x gives us 4x squared. And there is one x which is outside. Now open the bracket by this x value. Okay, so we will get 480x minus 60x squared. minus 32x square plus 4x cube. Now this is x square and here is x square. So minus 60 minus 32 gives us minus 92x square. Here we have 4x cube and plus 480x. This is the equation of the volume. Now take the derivative. So the derivative of 4x cube, 4 times 3, that is 12, and then x squared minus 92 times 2, we will get 184x plus 480. Set the equation equals to 0. And I told you many times that whenever we have the quadratic equation, in order to find the value of x, you must factorize the equation. So either factorize it mentally or take the help of the calculator, and in the calculator, if you have the scientific calculator, go mode 53, or if you have the graphic calculator 980 9860 G2SD, then equation F2 F1. So we will have the x value equals to 12 and x value equals to x is equals to 12, and that is x equals to 10 over 3. Okay, so 10 over 3, that means that it is equals to about 3.9. Okay, anyway, we have two equations, so it is almost 3.33. So after that, what we have to do? We have to see that which values we are going to take and which values will give us the maximized volume. So let's replace this volume part with the x value, or let's try to do our first derivative test. So 3.33, and here put the 12. Okay, put these values, take any values and put it in our volume equation to get the maximized or the minimized thing. So we will have 4x cubed. So put any value less than 3. Put any values less than 3. Write in the equation and get the positive or a negative sign. Then choose another interval between 3.3 and 12 and put it in the equation in the first derivative. Similarly, okay, so let's try to take the value which is less than 3. For example, if I take the 1, I will get a positive sign. If I get the 5, then again I will get a positive sign. And if I write the 13, I will get a negative sign. Which means that from positive till negative, it means on the 12 I have our maximum value. So now put in the value in the equation of the volume to find the final volume, that is 13 minus 2 times 12, 16 minus 2 times 12, and then 12, and find the final answer of the volume, when the volume that would be inch cube. So you may write in the calculator and get the final answer. So that would be your final answer.